This is chapter 5, closure number 3. It says solve the following systems of equations algebraically. Alright, so we're not graphing. So we're either going to use substitution, elimination, or equal values. Alright, so substitution is when we have a variable already solved, like x equals something or y equals something, and then we plug that, whatever that equals, into the other equation. Elimination we use when the x's and the y's are together on the same side, just like in problem A. Notice we have x and y, and then in the bottom we have x and y. So we want to eliminate, so we want to cancel out either the x's or the y's. We want to get 0 x's or 0 y's. And if I look, this is x and x, so I could subtract x minus x, and that's going to give me 0 x's. Now I just have to keep in mind that I am subtracting everything. So I'm going to do 2y minus negative y. And if I subtract a negative, I'm actually adding a y. So I have 2 plus 1, that's 3y. And then if I'm subtracting, I have to do that same thing over here on this side. 17 minus 2 is 15. And then I divide by 3, and I get y is 5. Then I also have to figure out what x is. So I'm going to plug in the 5 for the y into either equation. It doesn't matter. I'm going to go with the bottom one just because the numbers are smaller. So I have x minus, I'm going to plug in a 5, equals 2. I add 5 to both sides, and x is 7. So that's your answer to A. Need to get a different marker here. See if this one works. Okay, so this one, same thing. X's and Y's are both on the same side, which means I'm going to use elimination again. Alright, now this time though, I can't eliminate those. That's going to, if we add them together, we get 6. If we subtract them, we get 2. Same thing with the Y's, I can't eliminate. So I need to get this, I need to get either the X's to have the same number or the Y's to have the same number. So what I'm going to do is I'm going to multiply the bottom by 2 so that I can get a 4x on the bottom and a 4x on the top, and then if I subtract them, they will cancel out. So if I multiply by 2, 4x plus 12y, and I have to multiply by 2 on the other side, so I get 32. I'm going to go ahead and write the top equation down again underneath. 4x plus 5y equals 11. Now if I subtract these equations from each other, my x's will cancel. I have 12y minus 5y, which is 7y. And I have 32 minus 11, which is 21. And then I divide by 7, so y is 3. And now I need to plug in the 3 for the y again. So I'm going to go back up. I'll just go to the top equation this time. So I have 4x plus 5 times 3 equals 11. So I have 4x plus 15 equals 11. I'm going to subtract 15 from both sides. So I have 4x equals negative 4, and divide by 4, and I get x is negative 1. That marker's not any better. Okay, switch to a pen. For letter C, notice on this one I have x equals. That means I'm going to use substitution because I can substitute this for the x. So I'm going to put 4, then I'm going to put a parenthesis, 1/4 y minus 1, then minus 3y equals negative 10. So 4 times 1/4 is 1y, so I'm just going to put a y. 4 times negative 1 is minus 4. Then I have a minus 3y equals negative 10. So I'm going to combine my y's. Y minus 3y is negative 2y. minus 4 equals negative 10. I'm going to add 4 to both sides. Negative 2y equals negative 6. Divide by negative 2. And y is 3. Then I have to plug that in. For the y, I'll put it in the second equation. So x equals 1/4 times 3 minus 1. So that's 1/4 times 3 is 3/4 minus 1. And if I have 3/4 and I take away 1, it's like having 75 cents and owing somebody $1. So I'm negative 1/4, or negative 1.25 cents if I think of it like money.